about ZK products, where we break them down with rich flavors and sweet insights. My name is Omer, and I'll be co-hosting this show together with Queenie. Today, we are happy and thrilled to be joined by Ismael, co-founder and CEO of Lagrange, the infinite proving layer. Ismael, it's great to have you on the show.
Thanks for having me, guys. Good morning.
Definitely long overdue. In fact, it feels like interviewing you is kind of like should be in a starter kit for every respectful crypto podcast. I guess before we break down Lagrange and the infinite proving layer and more surprises that you guys are cooking, let's start by with the basics. Maybe a quick introduction.
Yeah, for sure. So yeah, I think you have a good point there. I kind of do the rounds on the podcast. I've been on a lot of them. So excited to be here. I've wanted to be in this one for a while. But by introduction, as you mentioned very well, I'm the co-founder of Lagrange. We're an early stage ZK company, actually we're a later stage ZK company right now, that focuses on the generation of zero knowledge proofs. We have a decentralized prover network operated by some of the top operators in the space, people like Coinbase, Kraken, OKX. We have a number of owned products that Lagrange runs on top of that, things like our ZK coprocessor and DeepProof, a ZK machine learning library that I'll share more about today. And we also work very closely for proof generation with very large roll-up ecosystems, people like ZK Sync, people like Caldera, people like AltLayer, people like Polygon, etc. I like to say Lagrange is the largest proof generator in crypto right now.
So just before we we dive deeper, a quick temperature check. So we recently held the ZK event at Denver. Wanted to ask you about your impression. Where are we as an ecosystem?
Yeah. So I posted something on Twitter the other day that got a lot of engagement. It was a comment I made that I worry about the short-term positioning of Ethereum, though I believe in it wholeheartedly long-term. And ETH Denver was very recent in my mind when I posted that. And I found ETH Denver a very concerning conference. I look at the companies that are being built on Ethereum today, and very few of them originate net new businesses or net new business. Almost all of them are sitting within the existing transaction supply chain, either single chain or cross chain, and are trying to capture BIPs on asset transfer. The story I like to say is like, okay, you can take a cross-chain protocol, something like Layer 0, Axler, et cetera, and say that's maybe 5 million revenue a year. We somewhere along the lines decided that we're going to modularize all of the stuff on Ethereum. And so now we have intent protocols and solver networks and intent expression languages and pre-comps that, one of them will make 5 million and pay $1 million to the other 4, or $1 million and change to the other 4. And so effectively, you just created double the amount of accounted revenue because you're just having one protocol pass the fees to all the other ones. You're not actually originating any new business. You're just passing around the same transaction volume in a circle. And this is what a lot of what's happening on Ethereum is right now, right? You take a roll-up stack and now you build the verification layer and the proving layer and the sequencing layer and the DA layer and all of this accessory technology that just rent seeks the same user transactions. And this is like a bad habit that Ethereum has fallen into over its last cycle because infra multiples have been so juicy for private market investors to deploy into. And this is a very big concern I've had with the Ethereum ecosystem as a whole. And so I think right now we're seeing a drawdown in ETH price, and we're seeing kind of the collapse of a lot of this, what I'd call purposeless middleware. And this is a good thing for the space. This is what's going to allow Ethereum to accelerate long term. It's dropping the baggage.
Thanks for the take.
Of course.
So then will Lagrange be the saver for Ethereum?
Yeah, that was a bold statement, but I like to think in some ways we will be. Specifically with the work that we're doing with ZK machine learning, there's a unique opportunity to move actual use cases from Web 2 on-chain. Not rent-seeking the existing 30 users who want to rotate their transactions across the newest roll-up to farm points, but to actually take things that exist and are useful in the Web 2 context and to decentralize them. Specifically intelligent systems, the core of how almost everything is being built today.
I actually want to start from the beginning, or at least, some kind of a beginning. I believe that you were the first to launch a proven network. And I'm very curious to hear about the experience involving that launch. And also what happened since then.
Yeah, so I appreciate you guys giving us the due as the first people to launch a prover network. That's a pretty contentious statement, given that everyone who does anything, no matter how late in crypto, likes to say they're the first. But I believe we are the first people to have ever launched a prover network. We did this on mainnet. We did this last June or July, and we had it operated and still have it operated by many of the top operators in the space and provers in the space. People like Coinbase, Kraken, OKX, P2P, Figment, Blockdaemon, like institutional grade operators who ran in many cases their first prover with Lagrange. And that's a big accomplishment that we really like, right? There's a lot of people in the space who validate for, the top 20, 30 largest chains and have never run a prover. And would have thought it was incredibly difficult and it would be just something that they'll do someday, but there's no concrete opportunity to do that. And many of those operators have run and continue to run their only prover on our network. We like to think of it as like an institutional grade proving infrastructure that powers all of our applications and many of the applications of our friends. And so since we launched that, we've been integrating the prover network with many of the top many of the top ecosystems in the space that have a high order flow for proof generation. People like ZK-Sync, people like Polygon, people like Caldera, people like AltLayer. And in all of these situations, there's kind of the same problem statement. And that is, hey, I have a bunch of proofs I need to generate, right? I am currently generating these on my cloud provider. I want to drop my costs. I want to increase my liveness guarantees, and I want to have more censorship-resistant proof generation. And in all of the situations, what we can offer is this institutional grade infrastructure that's battle tested on our own products and battle tested by many of the top roll-up teams in the space. And that's something that we find very exciting. So we did a very big announcement earlier this year with ZK-Sync. We did some other ones with Caldera. We did some other ones with AltLayer. We do a lot of great stuff with the Polygon team. And also we have our own products, our coprocessor and DeepProve, both sitting on top of our network as well.
So the proven network, it's what you now call the prover layer, the proving layer. Is that okay?
Network layer. It's the crypto vernacular.
I guess that like naming is one way to differentiate. How about other ways, to differentiate from other proving networks?
Yeah. So I mean, like all proving networks are roughly the same. And like a bunch of them are going to like come up here and be like, no, mine's really different, but they're like really not, right? You effectively have a mechanism with which you orchestrate the assignment of work, and then you have a bunch of people who are willing to do that work. It's a resource market, right? So ostensibly, a proving network is no different than a compute marketplace for AI or a compute marketplace for anything. It's a very well-defined architecture. The same way that like a blockchain for enterprise is not ostensibly very different than a blockchain for NFTs and a blockchain for some other application-specific purpose. So what a prover network is fundamentally is a double auction used for resource allocation. And so our network, one of the things that I'm going to say makes it unique is the fact that we have actual published research backing the mechanism design that we use for our proof generation and proof assignment. So our team authored a paper earlier this year called DARA, Double Auctions for Resource Allocation, which presents a mechanism with which a prover market or any type of resource market ranging from proving to AI to storage, really to anything you want, can have an incentive compatible design for assigning work within a series of workers in the network. And it's based on a double auction, which you can think of like an order book. So you can think of it like Binance for proof generation. And requests come in. It allows the requester to express price preferences over generation, right? You can think of a bid on an exchange. And then it allows people who are generating those proofs to express price preferences over generating them. You can think about that like an ask on the exchange. And then there's a composition rule that allows us to close the bid-ask spread, which is how you kind of market make. And through that, we're able to have this very fluid market for proof generation that has really an unbounded scale of what it supports.
All right. So you are unique in both science and engineering.
I like to think I am.
I want to ask about whether you see any interesting use cases so far using the network.
Yeah. I mean, there's a lot of great stuff we're doing on our coprocessor, which for those of the listeners who don't know is a SQL-based coprocessor which allows us to prove SQL computation over blockchain data or any kind of exogenous third-party data. And this is really great if you want to build something on-chain that needs data as part of its protocol function, where generally it won't be able to access that data from the smart contract. So think, rewards programs, think, dynamic rate lending, think asymmetric fees in AMMs. Just like a lot of these data-rich and expressive applications aren't possible today on most blockchains. And so a lot of that stuff is now possible on Ethereum and on L2s thanks to our coprocessor. And I'd also say, I'd be remiss if I don't mention that DeepProve, ZKML, also drastically expands the design space on blockchains in ways that I think people don't really appreciate yet. Like AI x crypto is fundamentally changing the developer pattern of what it will be to interact with a blockchain over the next 2 years. Crypto as we see it today will not be crypto in 2 years.
Okay, so if I understand correctly, the coprocessor technology is kind of like sitting on top of the proven network, like they're interact in a way, or it's like a tool that you provide for developers building apps that are going to be using or running on the proven network?
Yeah, so I think the best way to think of it is a prover network's a resource market, right? So you could generate a proof for a rollup, you can generate a proof for a coprocessor, you can generate a proof for a bridge, you can generate a proof for a machine learning application, whatever you want, right? It's effectively a way to match people who want to provide compute with people who are requesting compute for proof generation. And that's what our network does. And on top of that, we have a bunch of stuff that people would use to generate proofs, like the types of proofs they want. They could want proofs for rollup, as I mentioned. We work with a lot of rollup teams. They also want proofs for their applications. That's what the coprocessor generally does. Or they might want proofs for machine learning, which is what our DeepProve library does.
So going back to the differentiators, so it's now we can add another one, right? You have also the tools that you offer, like the coprocessors, which I guess while there are many proven networks out there, there are much less ZK coprocessors that are available. So this is another one, right? And now you mentioned that there's also an AI tool, right? A ZKML tool. Do you want to maybe introduce it formally?
Yeah, so we just announced that our team is launching DeepProof, which is a first of its kind ZKML library that is orders of magnitude more performant than the closest comparable. In our announcement, we mentioned a figure 671 times faster on, in this case, we benchmarked certain CNNs that were larger, certain large CNNs, were 670 times faster than the closest comp. I mean, it's an astounding number to be like, I'm 3 orders of magnitude almost faster than anybody else. But that's the position of how fast this library is. And this doesn't even include GPU acceleration or ASIC acceleration. Actually, Omar, we should maybe talk more about this offline, but we expect it'll be an order of magnitude faster than the number I'm mentioning once that stuff comes in. But what makes this so exciting is that when you look at AI, it has a trust and safety problem. And when you look at ZK, it's a technology that sells trust and safety. So they pair perfectly, right? I mean, all the way from, the printing of rogue gene sequencing to AGIs compromising, all digital media we will consume, all the way through to AI used in defense systems that could go rogue. There's massive concerns about AI trust and safety that are becoming increasingly top of mind, right? How do we ensure that there's not a civilization-level extinction event created by AI in the next 10 years? There really isn't a good mechanism to ensure that, right? You can talk about regulation, you can talk about restriction on compute capacity, you can talk about licensing models, and all of these stuff that a bunch of kind of the top AI safety researchers are proposing. None of that gets at the core issue that these models, when left unchecked, have near unbounded amounts of potential output domain. What ZK lets you do is fundamentally verify and prove and assert trust over something. And so by proving the execution of a model, you can constrain that output, and you can ensure that the model is running correctly and is not behaving in a way that's adversarial to humanity or towards its intended function. And that's an incredibly powerful concept, and I think people don't yet understand what that's going to do and how that's going to impact not just AI and crypto, but AI more broadly. And then, there's obviously the really fun part of ZKML, which is it lets you take AI and put AI on chain in ways that were otherwise impossible. You can build unstoppable models. And that's something that just frankly is going to open up the design space for building on a blockchain drastically. Like, I started this by talking about like a zero-sum mindset I see on Ethereum, where it's like my rollup is going to take liquidity from your rollup, and then my sequencer is going to take fees from your sequencer, then my proven network is going to take fees from your proven network. Like, we can fundamentally shatter that zero-sum game of what Ethereum is right now and onboard tons of net new applications and tons of net new things that people now have the capacity to build.
Can you actually break down how Lagrange ZKML prover works at a high level?
Yeah, so at a high level, you take an Onyx file as input, which is a representation of a model that you can export from PyTorch or Keras, whatever library you're using to build your model. You're then able to put that model or that Onyx file into what is in essence a compiler, which parses the Onyx file and spits out circuits for each of the modules contained within that. We use a GKR prover based on SumCheck and Basefold that is very, very performant from our research team. And then we're able to prove that given some input, the execution of the model gives some output. And you can do that in theory without revealing what the inputs are and without revealing what the model is, which actually opens up the design space of privacy with ZKML in a very interesting way.
Then I'm curious, what are the key advantages of Lagrange ZKML over other solutions in the space?
Firstly, it's fast, right? I mentioned the number, 671 times faster. And you can go through all the benchmarks, and they're all public right now. But there's some models that were like 50 to 100 times faster on. There's some models that we're up to 670 times faster on. And we expect that once we increase the size of the models that we're benchmarking, the performance delta compared to our comparables will get even larger, right? When benchmarking on equivalent hardware, like we could run our ZKML library DeepProve at model sizes that the closest comparable would just blow up. They would not be able to run those machines properly with it, right? It would blow up memory. It just wouldn't work. And I mean that's kind of the one of the big differentiators. It works and it's fast. And the other big difference is that you can start doing stuff that are non-trivial as a result of it working and being fast, right? You can start actually using this in production for applications on Ethereum in DeFi, for example, or in wallets where you want to move to natural language interfaces. You can start using it for like decentralized medical diagnostics or federated learning and training of like diagnostic models in joint contexts with privacy concerns over disclosing weights. There's like a lot of stuff you can now do when ZK machine learning now has been made practical that were otherwise infeasible before that.
But I'm super curious about
Yeah.
the magic of making
Yeah.
it so fast.
Yeah. It's just well built, right? We have a fantastic research team. So our chief scientist, Babis Papamanthu, is one of the chairs of the cryptography department at Yale. And then another of our distinguished researchers, Dimitris Papadopoulos, is a professor at HKUST, who's authored a bunch of great works in ZKML in academia. And then we also have a fantastic team with Nicola Gai, Shravan Srinivasan, and Chris, who are three of our researchers and research engineers who all have very distinguished academic and industry backgrounds. And collectively, we have a very differentiated set of people who are actually building this stuff. That's substantially, I would say, more acclaimed than our closest comparable sets, and that has just let us be a lot more performant than what we've built. And then also, there's an advantage you generally get in crypto if you're a later mover. where you can just pick a faster proving system, and that's what we did. Like the version of sum checks that we use is just very, very fast. We hand wrote all the sum checks for different operators in the Onyx file, and so it's just way more performant than, for example, something like EZKL, which is open source and it's built on Halo 2, and Halo 2 is much older and has performance concerns and performance constraints. So, we have a very good team who's able to build something performant, and then we also made design decisions that just made it faster.
Cool. Can't wait to try it out. So, and you also just mentioned it enables both privacy preserving
Yeah.
features and also inference verification, right?
hmm Yeah, privacy preserving features are something that we're very excited about, right? I think, I started by saying a little bit earlier that AI has a trust and safety problem. It also has a privacy problem. A lot of the things that we value in online systems, things like privacy, things like certainty of function, aren't present in AI systems, right? You don't have the same properties of explainability. You don't have the same ability to have robust client-side private information, and you just require to send everything to a model hosted somewhere that could be mining your data. And so that might sound trivial when it's just a chatbot, but if these are, cameras in the street that are streaming all of your data to a central repository, if these are, people pooling your medical information in untrusted servers, it starts becoming very problematic. And it starts becoming these kind of Orwellian futures that we kind of hope the world never becomes. And so what ZKML lets you do is to be able to verify that a model runs correctly, and then to be able to verify the model runs correctly over private inputs. And so when combining that with things like MPC or things like FHE, you can support like remote proving and remote inference over truly private data. And that's something that we think is actually probably a 0-to-1 use case in many ways for a lot of this decentralized proving infrastructure, where you can start going to the OpenAIs and the Inflections and kind of the Perplexities and all of these very large Web2 companies and say, hey, you can now offer your users truly private access to your models, where they can be, they can use models that are context aware, that are truly private end to end. And that's something that's not possible currently.
Cool. And also, AI models are becoming more and more complex these days. So, how does Lagrange ensure the ZKML remains scalable as
Yeah.
models grow in size?
That's a great question, right? So I started by saying it's fast, and that's good. But you have to keep getting faster. I think the great thing is models are getting bigger and more complex. I mean, within reason, right? I think there's a push right now to kind of move to the smaller models, like, sub 40, 30 billion parameter range. And some people think we're going to get 100 plus billion parameter models, but we'll see, right? But there's a continued push to make models larger and more complex, roughly, and there's a continued push to make ZK faster. It's completely separate from ZKML, right? There's work done with building more performant proving systems. There's work done with building more performant hardware, ASICs, programmable cryptography chips. There's work done building libraries to make existing GPUs, to make proving on existing GPUs faster. And so there's kind of like an arms race in ZK to add verifiability to everything, and there's an arms race in AI to add machine intelligence to everything. And so the ability for ZKML to be practical just depends on whether or not ZK as an industry can move fast enough to keep pace with how AI is moving. And as someone who's been building in ZK for 4 years at this point, or running a company in ZK for 4 years at this point, I can say confidently, I believe that ZK is actually moving faster. That we're seeing an order of magnitude improvement in performance every year and decrease in cost every year with ZK systems. And that's been consistent over the last 4 years. And we're not seeing that with AI, right? AI is getting much faster very, very quickly, but it's not to the same extent ZK is. And so, I feel very confident in making the bet that ZK can keep pace and ZK can become increasingly performant for proving inference and training as well.
Cool. I think there are also some teams that are using TE to, to achieve some similar goals here. So
Yeah.
yeah, shall we or would you also consider other cryptographic solutions to be integrated into Lagrange?
Yeah, Lagrange is a ZK company, right? Like you can break a TE with enough money, or any TE, right? It's $1 million, $2 million, $10 million. So it just depends on if what you're doing in the TE is valuable enough that it's worth breaking it. I think intelligent systems, when we're talking of drone navigation, you know, access to DNA printing and access to models that are doing DNA printing, all of that stuff, when you talk about humanity level risks, gets quickly a lot more valuable than $1 to $5 million. And so I think TEs are nice, but there's a reason that we haven't seen them take off in crypto, because in open systems, TEs present a very big risk. Where TEs are great and TEs actually are used today is confidential computing in the cloud. Like Google Cloud and Amazon offer confidential computing services that are all based on trusted hardware. And I think there's actually a market there that exists that's maybe about, from estimates I've seen, $5 to $10 billion a year approximately, that will be completely eaten by ZK in the next 3 years. When the overhead of proving drops, it'll start just becoming a second thought to use ZK over TEs. It won't be in any way a question anymore. And so that's frankly a very good data point for why this stuff actually has an existing market that it will sell into and eat.
Yeah. So, so what are the limitations of the current DeepProof system? Like, where is it? Or let me ask it differently. What do you have on in the roadmap? What do you expect from collaborators?
Yeah, I mean, DeepProof is the first version of this, right? I don't want to say exactly how long it took us to build DeepProof, but it was started this year. And so the performance is incredible for something that our team built very quickly, but it's yet to be audited, which we will be doing this year. And it doesn't have all the features we want it to have yet. There's a lot of stuff we're adding. And we have a very beefy roadmap of stuff that we're adding. So there's certain model types and certain model sizes that we don't support yet, partly because our team just hasn't had a chance to benchmark it that high yet, and there's certain operators in Onyx files that we haven't actually built yet, that we have on our roadmap. We're adding support for LLMs next. There's also stuff that we want to do over training. We want it to be possible to do actual federated learning or training using the ZKML library that we have. We want to be able to fine-tune models. There's a lot of stuff that we're adding there. And a lot of that is not novel from a research standpoint. It just requires some time and some engineering work, which our team has on the roadmap. So I'd say if you go into DeepProve and say, hey, this is really fast, but it's lacking this feature, you can expect that this feature will come later. And if you don't see this feature on the roadmap, email me and we'll add it. We want this to be the most feature complete shelling point for ZKML development in the space. I think the amount of market opportunity that we generated by applications leveraging ZKML at their core is going to be very large, right? Where it's going to be an ecosystem effect. I'd also say that stuff involving training is going to be very big as well. Verifiably fine-tuning models, data attribution, provable data attribution, proving that the model was used and that certain people had their data being used to fine-tune that model. Therein, they should have some type of residual royalty, right? We talk about IP. Well, there is data provenance and data ownership that has as large implications in this wave of machine intelligence as IP had in the wave of human intelligence.
So to put it in scope again, this is yet another tool, a very important breakthrough. Congrats, by the way.
Thank you.
That you are putting out there and that can be used standalone and also might be used together with the proven network or with the help of the proven network.
It runs the proven network already.
Oh, amazing. So just going back to this narrative of ZK and AI, so there's a lot of promise, but what would you expect to see for the first applications? What would be reasonable to assume that we'll see soon?
So I actually don't like often talking about first applications because I think it constrains people to thinking about this like zero sum idea of Ethereum, right? Where like I only grow by taking demand from an existing application. But I mean, there are things, right? Like yield aggregators and these like automated DeFi hedge fund concepts, right? Where like you deposit your money into this protocol and it moves it around in a circle such that it generates you higher yield than if you were to just like leave it in Aave, or if you're just LP in the Uniswap. And that stuff's really cool, right? And that stuff's going to make money, and that stuff's going to be exciting, and that stuff's going to raise venture rounds. But a lot of that stuff is zero sum, right? Because there's a subset of people who want to deposit their money in DeFi, and you're saying take that money that's deposited into this LP contract here and move it into my LP contract, and I will have a better yield for you because I use AI. And that stuff's going to work. That stuff's going to exist. That stuff is amazing, but it is zero sum. The next thing that I think is right down the pipe is just replacing a lot of these like AIX crypto systems that use replicated execution with ZK. So, if we're doing a centralized inference for any purpose, and we're replicating that across n nodes, it becomes cheaper to prove that on one node and network around a proof. And there's a bunch of AI L1s that are being developed that have that problem, right? Where it'll become cheaper when they just kind of move to that beam chain model of prove and network around the proof instead of networking around the input to the models. And so that stuff's going to start moving towards ZK, and you're going to start having these like AI ZK L1s that people build. And then the next right down the pipe use case is like wallets, right? You're going to move to natural language interfaces in wallets, and I'm pretty confident in this over the next few years. So instead of you saying, hey, I'm going to go navigate around the web and find a website, and I'm going to use the interface and check the metadata of my transaction to make sure it's not robbing me. Then I'm going to hope it doesn't like show me the wrong metadata, and the safe on the back end is not rugging me, or someone with a man in the middle between my hardware wallet and the back end is not rugging me. Instead of all of that, you're just going to say like, hey, I want to buy a pudgy penguin, or hey, I want to buy some ETH at the lowest floor price this week, or I want to buy on the 7-day TWAP this week, and the agent you're interacting with is just going to go out and do it, right? They're going to take your money, they're going to have access to your wallet, and they're going to go out and do it. And that stuff is going to require ZK at its core, obviously, because otherwise the agent is just going to rug you, or someone developing the agent will just rug you. And so that's like this intent concept, but an intent concept that doesn't use formal semantics around specifying like how natural language converts into an intent. It just uses AI to allow the AI to infer a set of transactions that allow the intent to function. And that requires ZK once again at its core.
So we talked about the vision, we talked about next steps. I also want to touch on the challenges in building in general, not just like in building this DeepProof library, but just in general, kind of like building at the cutting edge of technology and building in the ZK space.
Yeah, so that's a good question, and one that I have a lot of very strong opinions on, having built in ZK for a while at this point. 4 years I've been running Lagrange. So I meet a lot of founders who say things to me like, hey, like I have this great idea, I'm going to use ZK for this thing. And the question I always ask is, who wants this thing? Don't tell me about the ZK. Don't tell me about how it works. Like, put a TE or economic security, and then tell me what the market already today is for that thing, right? And if there's no market on a different set of security assumptions that you're replacing, then there's no demand for ZK, because ZK is a technology that allows you to add trust and safety onto an additional market, right? That's why it pairs very well with AI, because there's a massive market for AI that has zero guarantees of trust and safety. And so you're selling trust and safety to the largest existing market currently in tech, or the largest, fastest growing existing market in tech. And that's like why it makes sense. But if you're like building ZK for some random purpose that sounds cool at a hackathon, there likely isn't a market, because you're trying to sell people ZK instead of selling people on why they should use ZK in an existing market that has demand and fee origination. And that's one of the big problems that I see a lot of operators run into. They don't look at a market for the current form of that market. They instead look at the technology as an exciting thing they want to build. This is why, like, if we look at, the number of people building ZK companies today, it's actually substantially smaller than it was a few years ago. There was a boom of ZK companies in like late 2023 through like mid 2024 that have kind of purged out because there wasn't any PMF in what they're doing. And now we have, a couple big ZKVM companies. We have, ZK rollups that are struggling in liquid markets, but they're still quite large. We have ZK TLS coming up. And then we have a couple proving infrastructure companies like what Lagrange does.
So I'm glad that you decided to answer the way that you decided to answer, because actually, usually we focus on product, but I did want to ask you more of like a personal question, right? So you were an investor in your
My past life.
Yeah, in your past life.
Unfortunately.
And now you are running a VC-backed company in the blockchain space. And I wonder how it's like how investors are helping you, or how is investor relations look like from your point of view? Yeah.
So we were very lucky that we have a fantastic set of investors, many of whom I respect not just as capital allocators, but as kind of mentors and as supporters of Lagrange. These include people at 1KX, Archetype, Founders Fund, Maven 11, and many of the other great people on our cap table. And we're very lucky that the syndicates that we had across both of our rounds were just tremendous investors, both in reputation and then in personal character. And so, as someone who was an investor and someone who now is an operator, I think it's very important to ask yourself what you want from investors on your cap table, right? Lagrange is a research company, so I don't need an investor who is going to try to do the research for me, right? I don't need an investor who tells me that they're going to go do research. That's like not going to happen. A lot of investors also try to like sell you, like junior investors try to sell you on like, oh, we'll give you like technical leadership, or like we'll give you marketing leadership. And like most core functions of a company should happen internal to that company. So your engineering, your research, your marketing, your go-to-market, all of that has to happen in your company. Where investors are, in fact, the most value add is in their understanding of markets and in the degree to which they are in tune with the narratives of crypto. The entire job of an investor is to understand markets and then allocate capital against where they think narratives and excitement in crypto are going, as well as to understand listing processes and exchanges and kind of all of the other players that fit into the space of crypto. And so leveraging investors for those things is generally very, very high EV because investors are experts in those areas. And so that's where we generally find the highest degree of value add. If I need to understand the dynamics of market makers, I can ask our VCs, and I can ask obviously our team that has familiarity with this. If I want to understand kind of the intricacies of listing processes, if I want to understand perspectives on what the hot narratives are going to be 6-12 months from now, wherein we can sell products that are directionally interesting, I will talk to our investors, right? If I want deep technical guidance, I talk to our research team.
So before we wrap up, Ismael, I have 2 more questions for you. So first of all, I'm curious if there's any misconception people have about ZK that you'd like to clear up?
Yeah, I want to clear up the misconception that ZK is expensive, or like ZK is too expensive to use. ZK is like one of the most cost-saving technologies crypto has ever accomplished and has ever had access to. And it's like the most cost-saving by orders of magnitude. People like look at the cost of generating a proof and they go, oh, it's like, $1 or $2, and like I need a lot of these, so it's going to be expensive. And they don't understand that the alternative is like crypto economic systems that have high capital costs. Like you look at, okay, I want to run a chain that's going to do decentralized inference across 150 nodes, and they're going to have to stake capital. Well, how much are they going to stake? Say conservatively 100, 200 million, right? And you're going to have a 10% capital cost to buy your third-party asset and stake it. So the annual cost of running that chain is like $10 to $20 million a year. That's a lot of money. You're not spending that much on ZK. Like ZK is probably the cheapest technology that a blockchain will ever access. There's no requirement for replicated execution. You are no longer constrained by the smallest node in the network, and you have zero capital cost over replicating that execution or having people stake to attest to something. So it's a net cost-saving technology, and it increases security drastically.
That's an interesting take. Is Lagrange also working on to even bringing down the cost of ZK?
Yeah, we are. Obviously, a lot of the work that we do with our proving systems generally is trying to build faster products that use more performant provers that give us a leg up on alternatives, right? I think I mentioned earlier that our DeepProve library is up to 670x faster than the closest alternative, and cheaper would be the thing I'll add.
Awesome. And one last question from me. So, how do you see ZK gonna evolve in the next 10 to 20 years?
Yeah, that's a great question. So I think ZK is a technology that's directionally correct. And I don't put that lightly, because there's very few technologies in the world that we can say are like directionally correct. Like, it'll be quantum computers, AI, synthetic biology, space travel, asteroid mining, and like ZK. There's like not a very long list. You couldn't say that like TEs are directionally correct, because you have no certainty that a TE will be useful in 20 years, right? If the cost of everything else drops, if the cost of ZK drops. You couldn't necessarily say that even cryptoeconomic security is correct over 10, 20-year time horizons, right? Proof of work was not really the dominant form of consensus over 10 years, right? We have most chains are proof of stake chains right now. We don't know what chains will be 10 years from now. There's most technologies you look at and you don't know if they're directionally correct. Slack or Riverside, I have no idea if this will exist in 10 years. You could bet on it, you can invest in it, and if you're right, you make money, but there's no certainty. ZK is arguably the only technology that we have in crypto that we know is directionally correct. Verifiable compute will eventually replace all compute. When we move to superintelligent systems, AGIs, there'll be an increasing imperative on verifiability and correctness of execution for Web 2 software, for traditional financial systems, all the way to crypto and Web 3. There's no limit to the size of that market. The TAM for verifiable compute is the TAM for compute, which is the TAM for knowledge work in the world of machine intelligence, right? So it's an unbounded size market, and it's one that we know is correct directionally. And that's what makes the technology so impactful to work on and so exciting, right? You're working on the frontier, but the frontier is something that actually matters over 10, 20-year time horizons. So to get back to the exact question you're asking of where ZK will be in 10, 20 years, I think it will eat the majority of computation. I think the majority of cloud software will be proven. I think the majority of software you run on your computer will be proven. I think every blockchain will be ZK. I think every application sitting in crypto will use ZK on a bunch of different touch points. I think every model will be proven in ZK. And I think almost everything in the world will be verifiable. That's the only way that you can ensure that there is protections in place against ASI and AGI and all of these kind of systematic or humanity level concerns that I think a lot of people worry about right now.
We're happy to hear that. So Snark Chocolate is with you on this journey.
Wonderful. Hopefully I can be on every year for the next 10 years.
Please.
Yeah. Hopefully every time a new product or a new release, that should be the goal.
I love it.
Yeah. So yeah, I guess with that, with that note, we can wrap things up. There is actually one small question we like to ask our guests before we depart, which is to name one project you are bullish about. Just one.
Just one. Just one. That's tough. There's a lot I want to shill. I'll say Eigenlayer. People are very concerned about Ethereum right now. I've posted things that express my concern about Ethereum, but it doesn't mean that I'm concerned about Ethereum over long time horizons. I think Ethereum is correct. I think there is just questions over whether or not its current leadership direction allows it to become its full form on the timelines that we all want it to be. And Eigenlayer is one company that I think is integral to Ethereum. I think it's integral to systems building on Ethereum, and it's integral to the long-term success of Ethereum, both the asset ETH as well as the network.
That's perfect. So with that, we'd like to thank you so much for joining us today. We learned a lot about Lagrange, about the ecosystem. Congrats on the new release of DeepProof.
Thank you.
Hope that it will bring a lot of AI security and safety to the world. And yeah, thank you again. Thank you, Queenie. We'll share some links in the show notes as usual. That's all.
Thank you guys so much for having me.